Hi, College Algebra Juniors. I'm sorry to be missing you today. The plan for today is we're going to take notes and then you're going to start some classwork or some practice based on those notes. You will not be doing anything outside of class, so there's no homework. Whatever you get done in class is great. Whatever you don't finish, we'll finish in class on Friday. We're only doing 2 days of notes leading up to finals week next week, and we're going to touch on a little bit what's called matrices. So we're going to do the background of matrices today. This video is going to be on the longer side. It's quite a bit of background that we have to talk about. And then we're going to use matrices on Friday. Friday's notes are going to be short, quick, easy. They're going to use the calculator the whole time, so make sure you have a calculator on Friday. And then, like we talked about, next week during the final exam period, you're just going to be taking a small quiz. This should be pretty easy, and it's meant to be a grade booster. It's not meant to be tough. So let's jump right in. First of all, what is a matrix? Well, you can see an example right here. It's a rectangular array of numbers. Each of these numbers is called an element. So we'll see we have 6 elements here. The first thing that we talk about with a matrix is the dimension of a matrix, and the dimensions are just the size. Here's what you need to remember. Dimensions of a matrix are always the number of rows by the number of columns. Okay, so here's how you write it. In this case, we have 1, 2, 3 rows. So we say the dimensions of this matrix is 3 by, we have 2 columns, so 3 by 2. That is the dimension of this matrix. That's the size of this matrix. So that's part of what's going to be in your homework. Oftentimes we're interested in when matrices are equal. So this is this part. Equality of 2 matrices. 2 matrices are equal if and only if all corresponding elements are equal. Okay, so we're going to do an example. Example 1. It gives us 2 matrices that are equal. These are only equal, like I said, if the corresponding elements are equal. What that means is the first elements have to be equal. Okay, so right away, that tells us that A equals 3. Then, our second elements have to be equal. Okay, so that tells us that X equals -2. And we're just going to keep going. Third elements have to be equal. Okay, so we get B equals -4. And then we'll see we get 3 equals 3. That makes sense, supposed to be equal. We get C is equal to -1. And then, of course, our last elements have to be equal as well. That gives us Y equals 1. So those are our 5 answers. So again, the big ideas here. Dimensions of a matrix, or the size of a matrix, is always the number of rows by the number of columns. And then 2 matrices are equal only if their corresponding elements are equal. So that's some basics. We're going to move on now to performing some operations with matrices. So we're going to add and subtract, and then ultimately we will end with dividing. Okay, so moving on next to adding and subtracting matrices. In order to add or subtract matrices, the matrices must have the same dimensions. Okay, so in example 2, in part A, we are adding matrices A and B, and in part B, we are subtracting the matrices. So one thing I neglected to mention earlier is normally we give a matrix a letter to denote that matrix. So this letter A denotes that entire matrix A, and this letter B denotes the entire matrix B. Before we add or subtract anything, we need to make sure that these have the same dimensions. Remember, our dimensions is number of rows by number of columns. So dimensions is rows by columns. Okay, so matrix A has 2 rows and 3 columns. Matrix B has 2 rows and 3 columns. That means we can, in fact, add them. Okay, so I'm going to rewrite my matrices. Matrix A is 2, -2, 3. I have 1, 3, -4. and I'm adding that to 5, -2, 6, and -2, 3, 5. Now, if we are adding matrices, we are adding corresponding elements. So the first elements get added. 2 add 5 will give me 7. Then the second one gets added. -2 and -2 will give me -4. So you're always adding the ones in the same spot. 3 will be added to 6 to give us 9. And then we're going to add everything in the bottom row. Again, all the elements in the same spot. So this will give us -1, 6, and 1. And what you'll notice is your answer matrix ends up being 2 by 3, which is what we started with. And that should happen. Whatever dimensions we start with are the dimensions that we should end with. Okay, so in part B, this time we're subtracting. Element, or matrix B rather, is 2 by 3. A is also 2 by 3. Those are the same, which means we can subtract them. The order here matters. B has to come first. So I'm going to have my B, 5, -2, 6, -2, 3, 5, and I am subtracting matrix A. Okay, our answer is still going to be 2 by 3 since that's what we started with. I would caution you to be very careful here since we are subtracting. So we're going to have 5 subtract 2, which gives us 3. We have -2 subtract -2. So -2 subtract -2, which gives us 0. 6 subtract 3 will give us 3. And then again, we subtract in the bottom row. -2 subtract 1 is going to give us -3. 3 subtract 3 is 0. And 5 subtract -4 is 9. And so that is our answer. So again, anytime you're adding or subtracting matrices, have to have the same dimensions. Before we keep going with this, I have one quick note. So something like A refers to matrix A. Instead, if I ask you for something like this, A of 1, 2, this is some specific notation that we need to know. Here's what this notation means. Lowercase letter means we are looking for a specific element in matrix A. So we're looking for only one of the numbers. This 1, 2 means first row, second column. Okay, so if we look at this matrix A, first row is right here. This is first column, second column. So first row, second column is -2. So this element would be -2. Now, on the other hand, if I asked you for B of 2, 1, that means I'm looking at matrix B, the second row, the first column, which also ends up being -2. So that's just a quick note. You might see that in your homework where I'm just asking you to pick out specific elements. That is the notation for specific elements. Okay, so let's add on to this. Next page, please. Okay, so here we're going to do what is called scalar multiplication. What that means is you're taking a matrix and you're multiplying it by a real number. So let's look at example 3. Again, we have matrices A and B. First thing we're going to see is A is 2 by 2, B is 2 by 2, so we can add and subtract them. Here is that scalar multiplication. So what that 2A means is that we're taking A and we're multiplying it by 2. So A is 1, -2, 2, -3, and we are multiplying that entire matrix by 2. What that means is all of the elements are multiplied by 2. So the first element is multiplied by 2, the second element is multiplied by 2, and so on and so forth. All of the elements are multiplied by 2. So then I'm taking matrix B and I'm multiplying it by 3. Again, all that means is we're multiplying all of the individual elements by 3. So we get 9, 6, 3, and 12. And then lastly, we have to add. And remember, we're just following order of operations. Order of operations, we have to multiply before we can add. So that's why I dealt with the 2 and the 3 first. Multiply first, then add. When we add, we're just adding corresponding elements. So 2 add 9 would give me 11. Negative 4 add 6 would give me 2. 4 add 3 would give me 7. And then negative 6 and 12 gives me positive 6. So that's my answer. And again, we got a matrix that was 2 by 2, 2 rows, 2 columns, which should not surprise us because that's what we started with. Okay, so then if we do 3b, again, we're going to start with this 3a. So we're going to take a, so the 1, negative 2, 2, negative 3, and we're going to multiply the entire matrix by 3. When we do, we get 3, negative 6, 6, and negative 9. Okay, so here's where we got to be careful, is with this. There's 2 ways we can think of this operation. We can think of this as 3a subtract 2b, like it's written. Or, instead of subtracting, we can think of it as adding a negative. So hopefully this makes sense to us, that subtraction is the same thing as adding a negative. So I will tell you, I prefer to add, not to subtract. So what I'm going to do then is I'm going to multiply by a negative 2. So I'm going to take b and I'm going to multiply by a negative 2 because then I can end up adding instead. So in our original, we're going to consider this as adding a negative. So we're going to be adding, but we're going to take b and we're going to multiply by negative 2 instead of positive 2. I would highly suggest that you show good work here because I often have students get confused with that negative. They can't remember if they multiplied by the negative or not, if they've already handled it. So please make sure that you show some clear work. If we multiply by negative 2, we get negative 6, negative 4, negative 2, and negative 8. And lastly, we're going to add the corresponding elements. So 3 add negative 6 is negative 3. Negative 6 add negative 4 is negative 10. And then we get a 4 and a negative 17. So that is our answer. Okay, so far we've added and we subtracted matrices. We talked about some background. Last thing we have to do is we got to multiply matrices. This one I will tell you, you're going to want to bring your full attention to the table because this one is definitely a little bit more difficult. So let's go on and do a few examples with multiplying matrices. Okay, multiplying matrices is different than adding or subtracting. When we add or subtract matrices, the matrices have to have the same dimensions. That's not the case with multiplying. In order to multiply matrices, the inside dimensions need to be the same. And so then the dimensions of the product, by product we just mean answer. So after we multiply, the answer is called a product. So after we multiply the product or the answer to our multiplication, the dimensions of that matrix is going to be the outside dimensions. Okay, so I know right now you're like, what the heck does this mean? It's going to be easiest if we do an example. So here's how we're going to start. You're going to write down the dimensions of both matrices. This first matrix has 3 rows and 2 columns. The second matrix has 2 rows and 4 columns. Now, if I asked us to add or subtract these, you would tell me that's not possible. Can't add or subtract because the dimensions are different. But can we multiply? Well, in order to multiply, the inside dimensions have to be the same. So that tells us that yes, this is possible. The outside dimensions tell us the answer. So our answer is going to be a matrix that's 3 by 4. So remember, that means 3 rows, 4 columns. So it's going to be 3 rows, 4 columns. Okay. This is where things are going to get a little saucy for us. Here's how you're going to multiply. you will multiply every row in the first matrix by every column in the second one. So I'm going to do this right now, and I'm going to put my work in this box. Here's how it works. This row will get multiplied by this column, and you're multiplying the corresponding elements. So we have 2 times 1 and 3 times -1. So 2 gets multiplied by 1, and 3 gets multiplied by -1. Okay, so then you're going to keep going that row, the next column though. So first element by first element, second element by second element. So I get 3 times 2. Sorry, misread my numbers. So I'm going to do first by first. So 2 times 2 and 3 times 0. Okay, and then we're going to keep going. Same row, next column. First elements get multiplied, second elements get multiplied. So the first element will give us -4 when we multiply. The second element will give us 9. And then first row, last column. First, first, second, second. So 2 times 3 would give us 6. And then 3 times -4 would give us -1. Okay, so I'm going to put my answer all the way to the left. I know that my work is a little skewed. In the top row, I'm going to have 2 add -3, which is -1. So what I'm doing is I'm simplifying these before I go to the next 2. My next one, I'm going to get 4 add 0. So that'll give me 4. -4 add 9 will give me 5. And 6 add -1 will give me 5. Okay, so that's our first row. We're now on to the second row of our product matrix. So this time, we're going to multiply the second row, so this blue row, by each of the columns. And that's going to give us these 4 elements. So for our first element, we're going to do second row by first column. And remember, we're multiplying the likewise terms. So -3 times 1 and 1 multiplied by -1. So -3 multiplied by 1 will give us -3, and 1 multiplied by -1 will give us -1, which gives us an element of -4. Then we're going to do that same row by the next column, -3 multiplied by 2, and 1 multiplied by 0. So -3 times 2 is -6, 1 multiplied by 0 is 0. When I add, it gives me an element of -6. Okay, so we're going to go again. Second row, next column. Again, -3 times -2, and 1 times 3. So -3 times -2 is +6, and 1 multiplied by 3 is 3, giving me 9. And then again, that second row in the last column will give me -9 add -4, which is -13. Okay, so for our last row of this product matrix, we're going to do last row in blue times each of the columns. So remember, first element times first element, second element times second element. So 1 times 1 is 1, plus 3. Then I'm going to do that last row times the second column. So 1 times 2 is 2. -3 multiplied by 0 is 0. 1 times -2 is -2. -3 multiplied by 3 is -9. And lastly, 1 times 3 is 3. -3 and -4 is 12. So then when I add all of those, 1 add 3 gives me 4. 2 add 0 gives me 2. And then I get -11 and 15. So this is my answer. Remember, as we said earlier, the answer should be 3 by 4, 3 rows, 4 columns, which is exactly what we have. Okay, so I know this is a lot. This is a long process. It seems confusing at first, but once you get down the hang of it, things should go a little bit quicker. So we're going to do a few more examples together. Okay, if we look at this example 5, find the product. We're going to start again like we did in example 4. First, we need to know, is it even possible to multiply these? So you're going to need to note the dimensions of the two matrices. The first matrix has 2 rows and 4 columns. The second one has 3 rows and 2 columns. In order for it to be possible, these two numbers need to match. They don't, so we would say not possible. And that's it, you're done. That one's not possible. So I know this is a hard process. We're definitely going to do one more example together where we find the product. So let's look at the last example on the next page. Okay, find the product. So again, start with the dimensions. The first matrix has 2 rows and 3 columns. Second matrix, 3 rows, 1 column. Okay, so inside numbers match, which means yes, this is possible. Our answer is going to be the outside. So our answer should be a matrix that's 2 by 1, which means 2 rows, 1 column. So it's going to look something like this. Row, row. 2 rows, 1 column. Okay, so now let's actually jump in and do this product. We're going to be multiplying each row by the column. So starting off, we will multiply the first element by the first element to get -2, second element by the second element to get 6, and then third element times the third element to get -8. Okay, now we are on to the next row. First element times first element to give us -3, second element times second element to give us 2, and third element times third element to give us 24. Okay, so then once we simplify that, in the numerator, or the top of the matrix, not the numerator, the top, -2 add 6 is 4, 4 subtract 8 is -4, -3 add 2 is -1, -1 add 24 is 23. So this is our answer. Okay, so in this video, we talked about the background of matrices, dimensions, when matrices are equal, and then we talked about adding and subtracting matrices. And we said the matrices need to have the same dimensions. And then what we just talked about was multiplying matrices. When you are multiplying matrices, the inside dimensions need to be equal. So for example, if I have a 3 by 4 matrix and I want to add it to a 3 by 4 matrix, I can do that because the dimensions are the same. If I have a 3 by 4 matrix though, and I want to multiply it by a 3 by 4 matrix, we would say not possible because those inside dimensions are different. Okay, so this was a quick overview of matrices. What you're going to do right now is you're going to start the day 1 practice. So it's a worksheet. Get done as much of it as you can in class. And then when I see you all on Friday, what we're going to do is we're going to take some quick notes and we'll finish day 1 and also do day 2 practice. So get what you can done in class, turn it into Schoology. The expectation though is not that you will finish this at home. So don't feel the need to finish this at home. Get done what you can in class, turn it in at the end of the block, and we will finish the rest on Friday. Please help each other out if you have questions, because particularly with this multiplying, this is pretty tough. Good luck.